So, thank you first of all for staying so late with us. So, I will try to be as short as I can. So we'll see. Let's go. I work in a project. It started as a pet project first, and then suddenly it escalated. As for now, we have like contributions from many people. And the project is used somewhere. But it started in 2013. It's a bit some long time ago, say so. Do you remember like 2013, what the Python state was that time? So the idea was to manage basic network settings on Linux, and using external utilities was not an option because you have to parse the output of utilities, and it's inconsistent. So, and the first prototype was written in C types. It worked well. Suddenly, first users were QA. QA was in Red Hat. QA, like kernel QA. What does it mean? First, we have to provide stable API. Second, like it's long-term support, really long-term support. No background threads, no processes, no third-party libraries, and no C types. Because like it's QA, it should be reliable. And here's an example. This is an example of a code. It will work with like almost any version of this project down to like the very beginning. And the question is, do you know anything about Netlink? Does anyone knows about Netlink? Who uses Linux? Who? Okay, keep your hands. Who's using Apple Mac? Yeah, so like almost everyone. Did you think ever how do you set up network on your system? In the beginning, it was system call. I will return to concept of system calls, but like in Linux, they shifted to communicate with the kernel with some network protocol, and suddenly BSD systems are shifting there now, like. Netlink is working now on FreeBSD and will be used on macOS as well. What does Netlink provide? Like, almost everything. iSCSI, packet filtering, whatever. Thermal information. So, a bit about Netlink protocol. It's an important things about it. Like you see the length first, type of the packet or type of the payload, and sequence number. Keep in mind that. Does anyone have experience of Plan 9 from Bell Labs? No? There were a team of guys, probably you know them, Ken Thompson, Dennis Ritchie, all these like seniors who written Unix actually, and they didn't stop there. They thought, okay, Unix is okay, but like maybe we can do something better. In Windows, in Win API, it has, I promised you to tell about syscalls, like 30 to 40 thousands of system calls. In Linux, we have about like 400. And they say, OK, we don't need so much. Plan 9 has 30 system calls and is focused on files, actually. So everything is a file in Plan 9. There's Plan 9 and 9P protocol. Plan 9 system consists of like authorization server, a storage server, compute server. Does it tell something to you? Like, it's literally it's like OpenStack or Kubernetes or whatever, but in 1996. So many things came to Linux from Plan 9. It's namespaces, process, file system, network namespaces. It's like this concept of networking operating system came from Plan 9. And least like the last PF route protocol. It is an ancient brother of Netlink used on all the BSD systems. I found logos for Linux, for Plan 9. I couldn't manage to do something with BSD logo because I'm not smart enough to understand what they need to what they need to copyright their logo. So, okay. So as I told you, every packet in Netlink carries a sequence number or tag or whatever to identify the request. There may be there may be several concurrent requests on the wire, but they all should have different tags or different sequence number. And as you see, like you can receive broadcast messages from the kernel. You can send the request and wait for answer, and you can send the next request, not like getting an answer yet. So what the natural model for that is asyncio. Are you using? Are other people using asyncio here? Oh yeah. So like. So as I told you, is that like we migrated from threaded architecture to asyncio. So why not to use asyncio from the beginning? Like, yes, what is asyncio? Reason one, there was no asyncio at that time. So like I had no choice. We had to like use the only concurrency provided at that time it was threading. So the decision, I will not tell which decisions were poor or which decisions were good. I will tell only the decisions, and like you will just to give you time to think yourself like what was wrong. That was not everything, but like mostly. So Netlink API was provided and is provided as mixing to socket API. So you create a socket, you have low-level functions, methods, sorry, and you have higher-level methods that like cascade your data down to the kernel. And so thread safety from the beginning, as I told, like we had to provide some concurrency in the library. Despite the QA who was using this product, they didn't run threads, but we provided thread safety. Possibility to split the socket object. Why it's important? Because you are running new program in your main namespace, but you can work with like separate namespaces, with multiple network namespaces. Like you can run your program in the main namespace, but target some Docker container, or like that. And support non-netlink functionality. So it goes like that time, it's like ancient kernels before 3. They were like, there was no netlink support for bridge or bond interfaces. And still there is missing support for tune interfaces to create them, but we can remove them. So we created also like some API to work with IOCTL. And now about the thread-safe client code, how it was from the beginning. So if you have multiple threads and you have no management thread, because like you cannot run multiple threads, it's a requirement from QA. So you have a concurrency, you have multiple threads that are working simultaneously on the data stream from one socket. So only one thread will occupy the socket and will push the data, like it will collect their own data, and alien data will push to queues, and all the other threads are reading from queues. If there is no such queue, okay, then the packet goes to a broadcast queue. And as soon as the main thread, like that is occupying the socket, as soon as it exits, next thread comes in place. So all this machinery was implemented on mutices, on locks. And if you read it, so probably you will notice that something like it resembles something. Okay, implemented with threads. So it was ridiculous from the beginning. But okay, it worked. It worked for years. And don't try to read the code. But it is one method, only one method of consumer that was like implementing all this machinery and was implementing this thread switching on the socket. Why not? It's like it's not maintainable at all. There are like no people can do something with it. Why not to break it up? Why? Okay, that's why. Because we have, as I told, all this machinery was, all this cooperative multitasking was implemented with locks. So there were multiple flows with locks, overlapping locks in this method. So you just cannot tear it apart. And there was multiple read-write locks on queues that I just marked the lines where explicit lock calls, lock management was done. So just a nightmare. Okay, move to asyncio. Like, as I told, 2013, no asyncio at all. So why we had no choice. But 2018, asyncio support. That's like a request, a user request, a feature request from a user for our project. 6 years ago, okay, it took 6 years finally to start to work on it. I know I'm not so smart, but finally. What was decided? Async API as a first-class citizen. So we provide everything in async. And then we provide a wrapper, a synchronous wrapper around that to support the legacy code. So all the old code working with synchronous API would continue to work. That's the old code, like synchronous, and that's what we continue to support. And that's the new code, asynchronous. So like not much difference, maybe. Yes. That's async implementation of this of this consumer. That's it. Like, but it's not as simple as that. So like code metrics on the project before and after the change. An important thing, like it is not released yet. It's in a branch. So the main branch does not have this change yet. So this is a branch that will be released, like I hope, in the end of this month. So yeah, as you see, like it's quite a change. And these are metrics on the test code, like we have test suite for the project. So it didn't grow too much yet, but it will grow like that. So now what the problems did we met? The old code was mainly ad hoc with it was a spaghetti code, threaded spaghetti code. So it was a challenge to try to separate the levels, like the protocol levels were mixed before. Legacy, yes, we have to support legacy. We have some code working still in Red Hat QA that is testing the code, testing the kernel for regressions in the networking. So we cannot break it, no way. We just have to keep it. Beside of that, the project is used in OpenStack. So also not the best thing to break. So we'll see. Who knows OpenStack here? Who worked with the OpenStack code? Yes, so you know what's under the hood in OpenStack. Okay, there is an event loop, but not asyncio. So we'll see how it will work. I hope I will not crash the whole universe with that. So with red, I marked what came from the previous version, what was before, and the blue is what waits us ahead. Init is synchronous in Python. It's quite logical. If you run init, you have to get a ready-to-use object, always. It's a synchronous call. You cannot run it asynchronously. It's meaningless. So init is always synchronous. But our API, when it starts, it creates endpoints. And endpoint creation in asyncio is always asynchronous. So you cannot call it from init. So what to do? There are multiple ways to fix it. You can use a bake-in class method that will run init and then run some post-init asynchronously. You can run async with, also possible, I enter, I exit. But unfortunately, we had to support the old style API, and it should match the new style API. So we had to provide a class with a constructor, not a bake-in method. Thread safety. What did we do with thread safety? No more thread safety, just thanks, no. But instead, we're thinking, OK, but we can run a thread local sockets. If you run requests from multiple threads to netlink socket, you don't care which exactly file descriptor are you using. You just use API. So, OK, we create another netlink socket in another thread and run it, and suddenly, no race conditions, nothing like that. And we init socket on demand, because if you access the same object from different threads, for every new thread, a new underlying socket will be created. CI, we use PyTest. And PyTest asyncio works perfectly. I can recommend. Two things using the test objects in fixtures. As I told, the time when we started the project, it was quite hard to retrieve the information from the system and parse it. So we used our own object in test fixtures, our own code, our own API. That was a big mistake. Once you change anything in the core, it will break up all the CI. So, last. And now when you see all the, like, I told all the things like about what we changed, what we experienced, but now my opinion on that. No to thread safety. So if I can run a project with that can provide thread safety to users, no, I will never do it again. So users should care about thread safety. Never mix protocol levels. So once you mix it, it will be quite, it will be possible to split it up, but it will require a lot of blood. Yes to test-driven development. Even more test-driven development as you multiple screens. Okay. There is a documentation. And here is the source of documentation. We've listened to the report to the about documentation and Sphinx. That's Sphinx. It supports testing the code snippets within documentation. So, test CI features, test anything. Blah, 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 collect metrics. Yes, don't mix sync and async API. We do that, don't follow our steps, don't step that. It's no way. And on-demand resource init. As I told you, we provide sockets as thread locals, and we init it on demand. Yeah, those we defer the possible error. And those we break the rule, fail as soon as possible. And the last thing. No. Not this. Yes, this. OK, short demo, like 1 minute. As I told you, in Plan 9, that used the same, actually, protocol is like Netlink. But it used for IPC, and it used for, like everything, because in Plan 9, everything is a file. So it's like, it's IPC through files. This is a code. I fetch some information about conference from the site, names and avatars. And I create a simple file system providing this information. OK. That's 9p client. So let's read something. JSON. OK. And now, Tobias. Is Tobias here? No? OK, so I hope he will not blame us. So, and now read. I wrote the name to the file. And the file is provided by this routine. What happens? OK. Display. That's it. We can do some other name, like I can write me. So, but as I told, it's a file system. Can we mount it? Yes, we can. That's it. So all the same. So actually, this IPC is being used now. Okay, it's not released, as I told you, it's in a branch, but it's being used within the library now to communicate between threads, between processes, between namespaces, between nodes in clusters, using the same framework as Netlink, but 9p. So that's it. 25 minutes. Done.
Thank you, Peter. That was a fun talk. Any questions?
Oof, sorry. So that's it.
Well, I can add one.
Yeah.
So not directly related to the library, but what do you think about the giant mutex inside that link?
What about what?
The mutex inside the kernel.
Inside the kernel.
The Netlink socket. The RTNL layer.
So that was maybe not inside the kernel, but inside our kernel, like the library kernel. The library core. So yes, we were using mutasis. We were using locking because like it's multi-threaded. So actually, that's why we are moving to asyncio. We are just moving from any other concurrency than asyncio. So if people want to run parallel, so they can use multiple processes, serving microservices from them using IPC, provided by library again. So that's it.